Hello all, this is Santosh and welcome to TechDesign. This video is completely basics on NX assembly application. The topics that I'm going to cover in this video are creating a assembly, parent assembly, child components, all constraints, move components, joints, couplers, mirror assembly, pattern assembly. So if you are looking for our advanced NX video, please stay tuned to our channel. I'm going to get a new video on this topic as soon as possible. Now let's get started. Before going to start working on NX assembly, I'm going to give you a few terminologies that we are going to use in assembly workbench. Top-down assembly, bottom-up assembly, work part, displayed part, and loaded part. We need to understand these topics before getting into assembly workbench. So top-down assembly is a modeling that allows you to create a component at the assembly level. So by using a create new, we can able to create a new components, and we are going to create the component in the assembly file itself. We will take an advantage of an existing component's geometry and the location in order to design a new component part. So this allows you to consider size, space, and interference limitations. The next is bottom-up assembly. This assembly modeling involves creating individual parts separately and then create an assembly file and then add the components to the assembly workbench. The next topic is work part. So now you can see here assembly 1 is our work part. So whatever the work part it is there, it is going to show it over here. Suppose if I double click on the base part, so now the base part is going to be our work part. So now you can see here base part in assembly. So in this assembly, the base part is the work part now. So how we can be able to do any component as a work part? So just double click on it. It is going to be work part, or the other option is you can just right click and give it as make work part. Okay, so these are the two methods you can able to make a work part. The next topic is displayed part. So displayed part is always, assembly. Suppose if any assembly is opened, whatever that you are going to see on your window, that is going to be a display part. Suppose if I do open it in a new window, and now this is going to be our displayed part and as well as work part. So how we can activate the assembly workbench in NX? So you can just go to file and you can just switch on this application. So if it is off, this application of assembly is not available for you to use. So you can just go to file and switch on this application, and then once your assembly application is activated, you can able to see this tab assemblies. So if you are not able to see this assembly tab, what you can do is you can just right click here and switch on this assemblies from the menu. So once you switch on the assembly tab, now you can see here a lot of commands are available for us to use. So the first group is base group, which it is going to allow you the create new component or add a new component or creating a new parent assemblies. So the next group we have is position. So this will allow you to move the components and position them in a right place. And the next group is component group, which is allow you to create multiple components by using pattern and mirror assembly. And whatever the left side you can able to see, this is going to be our assembly navigator. So suppose if you want to switch to part navigator, there is an option here. This is going to be our part navigator. So now let's talk about assembly navigator. So when you see the assembly navigator, and you can see here there is an icon with a 3 cubes. So it is nothing but whenever you see the component with the 3 cubes, it is nothing but it is an assembly part, and whenever it has a single cube, that is going to be a single component. Now if I open any other assembly, you can see this is going to be your assembly file, and this is going to be our single component because it is having a single cube. And now you can see here there is a 3 cubes icon, which is nothing but again a sub-assembly. So this is our main assembly. Inside this main assembly, we have this particular sub-assembly, and inside this sub-assembly, we will be having maybe will have a component, or it may be again a subassembly. So now you can see, once you expand this, you can able to see there are two components that are single components inside this particular assembly. So this way you can able to see all the different kinds of assembly levels in the assembly navigator. And now if I expand this, you can see here there are multiple columns available on this window. Suppose if you right click here and go to columns, you can see there are multiple options available for you to switch on. Based on your work environment, you can switch on these options and make it available for you to see over in this window. Suppose if any feature is not available in this window, what you can do is you can just go to configure and you can just enter the particular attribute over here, say for example part number, and then you can just give add here, and it is going to be added into this particular column. If you have entered a proper attribute, then it is going to populate the part numbers. In NX, suppose if there are multiple components are available in the same assembly, it is going to show the components by multiplied by 2. Suppose if you don't want this to show, you can just right click on this and unpack it. So if you do unpack, you can able to see the two different line items for two different components or two different assemblies. So now you can see if this lower arm is also in a two quantities, and even this hinge pin is also in a two quantities. And now suppose if we want to unpack everything, so you can just go to right click on the empty space and you can just go to unpack all. So now you can see every single component is going to show in a different line items. When you are in an assembly workbench and if you want to open any of the component in a new window, you can just right click on this one and you can just go to open in a new window. So once you do that, you can see the particular assembly has been opened into a new window. And in this case, if you want to close this window, you can able to close it, but the part is not going to be closed. So you can see here the part, even if we close the window, the part is opened in this particular assembly. Now let us talk about these columns. So now we have a multiple columns here, but most commonly used columns are info, read and write, and modified, positions, and reference set, and then unit. So info is nothing but it will give the information about any component, if it is failed or anything that is going to appear over here. And now then it comes to read only. Say for example, if any component, if you don't have an access to read and write, so that options are going to be shown here. So now you can see here, this is read and write. So I have both access to read as well as write. And this you can see it is minimally loaded. So since it is minimally loaded, it is not showing whether it is read and write. So now you can see here there is a different icon here. It is nothing but it is, so this is also a read and write component. The next column we have is modified. Say for example, this is going to show an icon when you have modified any component, so that it will be easy for you to identify which are the components that you have modified and which are the components you need to save. Say for example, I am going to go into this upper arm and I'll just open it in the new window. And now what I'm going to do is I'm going to make this as a, I'll just create a simple point here. Okay, so I have created a point on this assembly, and now what I'm going to do is I'm going to close this assembly. So once I close this assembly, you can able to see here in the front upper arm, you can see it is modified. So we need to save it. Suppose if you want to save it, you can just save it by you looking at this modified column. So the next is position. So this position, regarding this position, I'm going to talk in detail when you are going to constrain the components. But as of now, this, if it is a completely circle, dark circle, it is fully constrained. And if it is a half circle, then it is partially constrained. And if it is completely white, so it is unconstrained. And then we have one more icon that is fixed. So fixed is nothing but the component is completely. The next column is count. So it is going to queue the number of components that are available in the particular assembly. So in this suspension assembly, we have 110 components, and particularly in this assembly we have 3 components. So this is first, second, and this is going to be our third component. The next column is the reference set. So regarding the reference set, I have already done a video in my YouTube channel. So you can just go to this reference set and check out that video. The next column is units. So it is going to display the unit on which the model is being created. Now there is one more feature that is very important in the assembly workbench is export to spreadsheet or to the browser. So if you want to export all these assembly with all the details, you can just right click here and go to export to spreadsheet or to the browser. So if you click on this browser, so you can able to see all the components and all its details are being exported. This is the basic introduction we need to know before going into creating an assembly. So if you go to assembly workbench, and now the first command we have is assemble. So once you click on this is a quick assembly tool that is available in latest version of NX, and you can able to choose the component and move it to the location and then assemble it easily. So now what we can do is I'll just select this third component which is already loaded, and in your case if it is not loaded, you can just go to open here and open it from the local or from the team center. So now I'm going to select this. So you can see here this is the component that is added, and in this assemble window what you can do is you can just move this like holding a component and move particular position, and once you move to the particular position it is going to show you the available constraints that we can able to provide. So once everything is okay, what you can do is you can just leave this and it is going to show what kind of a constraint you want to provide. So you can just give a touch alignment or whatever the required constraint, and you can just click OK, and it is going to create a particular assembly constraint. So this assemble command is not so user friendly. You can use the other assembly constraints which are available over here in order to assemble the components. The next command we have is add component. So this command allows you to add a component either which are already loaded into NX. Maybe it is in a suspension assembly or in a different assembly. So if you want to add any component which are already loaded in a NX session or from the local or from the team center, you can use this option add component. So you can just go to add component, and now you can see here loaded parts. So these are the list of loaded parts in the NX session. So not only in this suspension assembly, even from the other assemblies as well. So all the list of assemblies will be available over here. Either you can type the part number or the description or the name of particular component over here. It is going to filter based on your input. Say for example, if I give hub, so it is going to show only hub components, and you can choose the particular component and add it to assembly. So now once I select a component, you can see here assembly location. Either you can keep absolute work part or absolute displayed part. So I'm going to select the absolute work part and I'll just click OK. So as soon as I enter, you can see this is going to be added to our particular assembly. Suppose if you want to add a component which is there in the local or from the team center, so you can just go to add component, and here you can see the open. So you can just go to open, and this will allow you to choose the component from the local or from the team center, and you can select the particular component and bring it to over here. The next command what we have is create a new components. So this command we are going to use when you are doing a top-down assembly. So you have already created an assembly file, and inside this if you want to create a components, then we can able to use this command new component. So what does this do is it is going to create a new file. So once you click on a new file, it is going to ask you component name, layers, and all other things. If you want, you can just change it. And now what I'm going to do is I'm just going to click on OK, and you can see here the new model or the part component is being created. In this part, whatever if you want to create, you can able to create it by making it as a work part like this. The next command we are going to talk about is new parent assembly. So now you can see here, this is a suspension assembly, and inside this we have a multiple child assemblies or components. So suppose if you want to create a parent for this suspension, maybe any assembly which comes above this, you can able to create a parent assembly. You can just go to create a parent assembly, and as soon as you click on this, you can see here the suspension assembly whatever we have is now inside the assembly one. So this you can just make save as and create, give the name whatever you want. The next topic we are going to talk about is position. So inside this position we have multiple constraints to provide in between the components. So this is most important topic in the assembly workbench. Based on your understanding, you can able to give all the constraints using which you can able to complete the assembly. The very first command is fix constraint. So basically this fix is going to restrict all the degrees of freedom in the particular component. So now suppose if I go to fix and select this base component, and if I click on this, now you can see here in the position it is going to show you it is completely fixed. And in NX, suppose if you want to see what are the degrees of freedom that are active for any of the component, what you can do is you can just go to that particular component and right click on this and show degrees of freedom. So once you click on this degrees of freedom, you can see there is nothing happened. So you need to go to this bottom status bar. You can see here there are no degrees of freedom active. Okay. So this way, suppose if you want to see for this particular rod, you can just right click here, show degrees of freedom, and now you can see here there are a lot of arrows you can able to see, but in the bottom it is written there are 3 rotational and 3 translation degrees of freedom are active. This is the way how you can check degrees of freedom in NX. So now suppose you can see here, now these arrows are going to be here, and if you want to remove it, even if you hit escape or do anything, it is not going to remove. So in order to remove it, you can just give it as a update display. So once you give that, your arrows are going to be disappears. The next command what we have is touch constraint. So when you go to touch constraint, you need to give 2 faces or 2 centerline axes in order to have the component touch constraint. Now you can see select a motion object and select a stationary object. Say for example, in your case, if both the components are not constrained and they are free to rotate, and if you want to move one component, say for example, now this is the one component and this is the second component, and I want to move this particular socket near this rod. So now what I'm going to do is I'm going to select the face on this particular socket. So now I'll just go to motion and I'm going to select this face. So once I select this face, now I need to select a stationary object face. Now I'm going to select this. So as soon as I give, you can see both the faces are having a touch align now. So the one more way how we can use the touch is by center line touch alignment. So I'll just go to touch here, and now instead of selecting a face, this time I'm going to select a center line. So I'm going to select this center line as well as this center line. So now if you see, both the center line are matching each other, they are touching each other. So now suppose if you want to reverse this direction, you can just give on reverse and the component is going to reverse it now. And once you click OK, the particular constraint is applied to this component. The next command what we have is parallel. Just the same as this touch alignment, this parallel can be given to center line as well as the faces. Say for example, in these cases, as you can see here, this socket is not parallel to this particular cylinder. So now what we can do is we can just go to parallel, and I'm going to make this as a parallel to this particular face. So once you click, you can see now with both the faces are parallel to each other. So like I said, this parallel also can be given to a center line. So I'm going to select this center line as well as this center line. So now these two center line are going to be parallel to each other. So the next command is concentric, most commonly used constraint. So it is going to restrict and touch each other. So that is why it is mostly used when it comes to fasteners like nuts, bolts and screws. So in this case, what you can do is if you want to make a concentric of any two circles, so you just need to select this circle and this circle, and now they both has become a concentric. It is not only become concentric, it is going to touch both the faces of a component. Because of this touch alignment and as well as concentric constraint is most commonly used. So the next command is distance. So here you can just provide a distance between the two faces or two center lines. So now I'm going to select a motion object face. So this is the one, and the other one is this, and now you can see there is a distance of 75 mm, and now if I want to make it 100, you can just give a distance as 100, and then you can just click OK, and now the distance between these two faces is going to be 100 mm. Similarly, you can just give the distance for center line as well. The next command what we have is bond constraints. So bond constraints is going to create a bond between the two components. Suppose if any one component is moved, along with that the other component is going to move. So in this case, now you can see here whatever the distance it is there, I'm going to keep it as it is, and I'm going to give the bond between this socket and this cylinder. So I'll just go to bond and select this and this, and I will just click on OK. So now if I see here, these two are bonded to each other, even though if they are not mating each other, they are bonded. Suppose if you move any one of the components, so I'm going to move this socket along this direction. Now as you can see, our cylinder is also going to move. Not only this socket, if you move this component, your socket is going to move along the movement of particular cylinder. So this way you can able to use this bond command. So the next command is auto align. So before going into auto align, I'm going to discuss about align first. So align, as the name suggests, it is going to align the faces or it is going to align the center lines. So now if I go to align and I'm going to select this face and this face, so as soon as I click, you can see here these two faces are completely aligned. Suppose if you want to reverse this, you can able to do it over here. So now let's move on to auto align command. So auto align is nothing but it is a combination of touch constraint as well as the align constraint. So it based on the selection method, it is going to give the constraint either touch or by align. So the next constraint is perpendicular. Say for example, if you want to do the perpendicular of any face or center lines, you can able to do it by this perpendicular command. The next command is align lock. So this is very important command when you are going to constrain the washer components like cylindrical components. So this is a component, suppose if you go to any kind of constraints, but you cannot able to restrict this particular component rotation along a z-axis because we don't have any face to give a parallelism or perpendicularity for this particular socket. In this case, you can able to use align lock. So what does this do is it is going to restrict the rotation of a cylinder along a axis. So we'll just go to here. So I'm going to select this and this center line. So now the touch alignment is given to this. Once the align lock is given, suppose if I go to socket and check the degrees of freedom, now you can see only the translation along z-axis is active. So the rotation is already constrained. So in order to completely constrain this, now we can just go to touch alignment and give this face and this face. So now if you check the degrees of freedom for this, now you can see there are no degrees of freedom that are active. So the next constraint is angle. So suppose if you want to provide any angle between the faces, you can able to give it. Say for example, from this face to this face, if you want a 30-degree angle, so now we can just enter 30 degree over here, and now you can see here these both components will have a 30-degree angle between the two faces. So here the last constraint what we have is, suppose if you want to do any component center of the other component, and this case you can able to use this particular constraint. So how we are going to use this? So there are multiple options over here. Based on your component, you can able to select this options. So now what I will do is I'll just go to 2:2, and then I'm going to make this particular socket exactly at the center of this particular base. So in order to do that, how we can do is we can just go to select two faces on this particular component and two faces on this particular base. So once you select that, and if you see from side view, now you can see the component is completely exactly at the center of this particular base. So these are the all different constraints that we have in the assembly workbench. The next topic I'm going to talk about is joints. So the first joint is hinge. So now as you can see, this is the model that I'm going to use in order to explain this hinge joint. So now as you can see, the hinge 1 is here and this is a stationary joint, and whatever the hinge 2 is there, it is going to rotate along this axis. So we can just do that hinge joint here, and we can make a simulation, like we can move the joint and check if any interferences are there. So how we can do, we'll just see that. We'll just go to hinge, and now you can see here axis on a first object. Okay, so we need to provide an axis, so I'm going to select this axis. Okay, and then we need to select a point, so this is the point, and now the second object and the second point. So now what I'm going to do is I'm going to give this point, so this is my vector and the point is going to be this point. So as soon as I give, you can see here it is being attached to this particular. So if I give any angle at this point, so angle will be fixed. Say for example, now this is 40-degree angle, and this particular both the hinges will be fixed and this angle is also fixed. So you cannot able to move it and check the simulation. So in the order to move it, so now I'm going to provide 90-degree as an upper limit and 20-degree as a lower limit. So in this 90 to 20, it is going to rotate if you try to move it. So now let's click OK, and now what I'm going to do is I'll just go to move command and select this particular hinge, and in this hinge I'm going to move this component by selecting this. So now as you can see, it is being moving by whatever the angle that we have provided, and apart from that it is not moving. So this way you can able to create the hinge assembly. The next command I'm going to discuss about is slider. So we'll just go to slider here, and we need to provide specify the vector and point. So now what I'm going to do is I'm going to specify the point at this level, and the vector is going to be along negative x direction. So I'm going to select negative x direction already, and the point is going to be center of this one. So how we can choose, we can pick it from here. If not possible, we can just go to point and go to between 2 points and select this point and this point. So this is going to be our between point, and we can just click OK. So now the axis on a second object. So I'm going to select this axis and my point is going to be this. So once I click, you can see the component has come and it is placed over here. So we are going to reverse this, and now if I give a distance, it will be fixed. Say for example, if I give 50 mm, it is going to move by 50 mm and it will be fixed. So I don't want to fix it. I want to check the upper limit and lower limit. So I'm going to give an upper limit of 150 and the lower limit of 0. Okay. So once this is done, we can just click OK, and then we need to simulate this and check. So how we can do, we'll just go to move component, and here we are going to try to move it. So now as you can see here, this particular component is moving along this direction. Suppose if you try to move it along this direction, it will not move because it is having a slider constraint. Okay, so only along this direction it is going to move, that too from 0 to 150, whatever the limit that we have provided, that is going to move. So the next topic we are going to talk about is cylindrical. So once I go to cylindrical, you can see the same options are available here. Specify the vector and point. So now what I'm going to do is I'm going to select this vector and my point is going to be this point. Okay, and then the second object, so I'm going to select this object and the point is going to be this point. So now as you can see here, it is properly aligned. So in the cylindrical joint, we have two options, distance and as well as angle. So if you want to give distance, you can able to provide it over here. And if you want to provide an angle, you can able to provide it over here. So in the distance, what I'm going to do is I'm going to give an upper limit of 50 and lower limit of 0. In the angle, I'm going to give 90 degree here and lower limit I will keep it as 0. So once I click OK, and now if you try to rotate this, so it is going to rotate by only 90 degree. You can see it is going to rotate by only 90 degree, and you can see here this is going to be attached perfectly at this location, so that the distance is given like that. So it is stopping at exact point. Okay, suppose if you want to rotate it, you can just rotate it, and you can see at this point it is locked. So this way you can able to use this cylindrical. So the next joint we are going to discuss about is ball joint. So in order to explain that, I have opened one of the assembly over here. So now let's go to ball joint. So now what I'm going to do is I'm going to select this cylinder for our axis, and the point is going to be center of this particular sphere. So now how we are going to select the center of this sphere? So we can just go to point dialog box, and here we can choose the center of arc, ellipse or sphere. So you can just select this sphere and click OK, and this is going to be our point. So again the specify vector, so here the vector is going to be along this direction. Again the point we need to pick, so this point can be picked from here, or else again you can just go to point dialog box and select the sphere here and select this point and click OK. So now as you can see, the particular ball joint has been come and fitted over there. And suppose now if you want to check, so we can just go to ball joint and try to move it. So now as you can see here, it is moving in all the direction. So this angle can be controlled, whatever the angle that you are going to provide, it is going to move it by particular angle, and you can move the ball joint. The next topic I'm going to talk about is move component. So I have already done a detailed video on move component. I will give the link in the description, but anyway I will just explain it to you in this video. The move component command will work only when you have at least 1 degrees of freedom for any component. If all the degrees of freedom are constrained in particular component, then you cannot able to use the move component. Say for example, you can see here this is the one plate and this is the another plate. So this is completely fixed and this is completely constrained. So if you try to go to move component and if you want to move it, so you cannot able to move this particular component. So what you can do is you can use this move component only when there is at least 1 degree of freedom is active. So now you can see here this is a bolt and it is not even constrained. Okay, so now if I go to move component, I can able to move this component. Okay, so now in movement of component we have multiple options over here. So you can see distance, angle, point to point, and many more are there. So I'm going to discuss with you most commonly used method. So the first one is distance. So as soon as you give the distance, it is going to ask you the vector along which you want to move. Say for example, I want to move along this direction, and what is the distance? So I'm going to give it as 50 mm, 50, and click on enter. It is going to move along this direction by 50. And suppose if you want to move along this direction by again 50, so in that case you can just choose it and give the 50 mm. So this is the one way by distance. So the next is by angle. So you are just going to specify the vector along which it is to be rotated. Okay, so along this angle, and the point is going to be this point. And now if I give the angle, it is going to rotate. So let me give it as 20. And if you see the head of this particular bolt, it is going to rotate. So if I give again 20 and hit enter, you can see it is rotating. So based on your requirement, you can choose the vector and you can try to move it by angle. Next is point to point. Say for example, if you want to mate 2 points from one component to another component, then you can able to use this particular point to point. So how we can use, we need to select from point. So this point should be my from point, and this should, so as soon as you select a 2 point, you can see the particular bolt has moved from this point to this point. And here the most commonly used method is by dynamic. So it is going to give you a handle. So you can see here, this is the handle, so you can easily move it along any direction, and if you want to rotate along any direction, you can able to rotate it and place it. Here the most important thing is, say for example, if you want to move this particular bolt, bottom of bolt, to this top of this particular circle, so in that case what you have to do is, you have to first move this dynamic handle to the bottom. So how we can move, so if you drag it, it will move along with this particular bolt. So in that case you can just move handle only. So now in this case only the handle will move, so you need to attach the handle to particular bolt where you want. So now I want this particular dynamic handle in the bottom, and now I will just switch off this, and now I'm going to select this point, and now you can see the particular bolt has been moved from this to this. So in this way you can use this move handle only option. So the next topic I'm going to talk about is pattern component and mirror component. So pattern component, like we have already used this pattern in the sketcher environment as well as in part modeling. So in the similar way, it is going to pattern the components now. So we'll just go to pattern component, and I'm going to pattern this particular bolt from this location to this location. So now what I'm going to do is, I'm going to select this component. So once I select this component, you can have multiple options here. So this situation I need a linear one, so I need to specify the vector. So along this vector I'm going to specify, so I'm going to go for count and pitch. So how many counts we need, including this original, is 2. Okay, and the pitch is nothing but the distance between the two components. So now we have a 80 mm distance from this hole to this hole, so I'm going to give it as 80, and I'll just click OK. Suppose if you want to pattern this along this direction also, you can use the direction 2. Okay, so detailed video on this pattern component is already provided in the description, so you can just go it and check out. So once I click OK, you can see the component has been patterned to this particular place. So now suppose if you want to mirror these two components to this particular places, so in that case we'll just use the mirror assembly. So once I go to mirror assembly, this is the window it will open, so you can just click on next, and now you need to select the components which you need to do the mirror. So I'm going to select this and as well as this. So I'll just click next, and we need to provide along which plane you are going to mirror it. So we don't have any plane here, so let us go to create a plane command here. So we'll just go to here, and now we need a center plane between these two. So what I'm going to do is, I'll just go to bisector. So I'm going to select this face and this face, so that it is going to create a plane at the middle point. So I'll just click OK, and now again we are into a mirror assembly wizard. So I'll just click next, and based on your naming, whatever the naming you want to put it for the components that are mirrored, so you can just choose it over here. So I'll leave it as it is, and I'll just click next, and here also we can just click next. I don't need anything over here. I'll just click finish. So as soon as I click finish, you can see here the bolts are being mirrored from this location to this location. So this completes the basic assembly workbench on NX application. I'm going to make one more video on advanced NX assembly tutorial, which includes arrangements, reference sets, suppressions, and many more. So please stay tuned and connect to my channel.